Well, hi, good morning, and thank you for joining me in my shop. Today is the 21st day of November, and the forecast is not quite snow. Not quite. Not here, anyway. Not quite yet, but soon. So, this radio, I think I ended the last video looking for B plus on the output tube, and I can't remember now, finding it low or finding it absent. I think I found it low. So I'm going to start right at that spot. I'm going to look for high voltage on the plate and the screen of this tube. It's a 6K6, which I took out of the radio so I could spot the key to make sure I could count the terminals properly. So on a 6K6, the screen is pin 3 and the plate, other way around. Plate is pin 3 and screen is pin number 4. 3 and 4 side by side. So I should find, I think we should take a look at the schematic. I was going to make an assumption there, but I think we should look at the schematic. Okay, this is the area that we're interested in, so I'm going to zoom in on that. My troublesome mouse here. There we go. So there, you got a voltage written right there, 235. This doesn't look like the draftsman wrote that. It looks like somebody else wrote that in. And that's for the plate, and that would be pin 3. We got 1, 2, 3. Because if you look hard, the key is marked right here. 1, 2, 3. Then we see the screen grid here at pin number 4. I think the number 4 is written right there. I wonder why. Why would they do that? They have the number, looks like, yeah, don't get distracted. So if we look back, we see the plate of the output tube is fed from the early side, or the input side of the pi filter in the power supply, where the filtering isn't as great. That's surprising to me, because it has a resistor here. I was going to say you have to go on the other side of the for crying out loud. Jim, what's the matter with you? Field coil. There's a field coil on this radio. 4,500 ohms. This must be marking the field coil. This says R12. Whoa, wait a minute. Let me just look at this speaker again a little more closely. Wow. Sure looks like a field coil. Okay, let's go back to that. It surely looks like a field coil. Now there's a hum. This is a hum coil leads here, coming from in there. I'm pretty sure that's what this is. But I got the right schematic up there. And yeah, definitely there's wires going into it. It's definitely a field coil. Let me put this tube in while I'm here. Okay. The problem I'm having is I'm dealing with about 4 different radios at once. I'm dealing with people over email with their radios, and I'm getting it all mixed up in my head here. Who's got what where? Okay, field coil, but the schematic shows just a resistor. That's a problem. That's a problem right now. In fact, let's go back and look at the schematic again. Okay, so these small capacitors suggest this is a field coil. This high resistance suggests it's a field coil. And there's no notes here. Let's look at R12 in the parts list. Is there a parts list? I don't have a parts list, I don't think. No parts list. Well, I think a safe assumption is this is a field coil, in fact. Even though they show it as R. Very surprising that they would do that. Okay, so the lesser filtered side is being sent to the output tube, and you might think, well, wait a minute, why the lesser filter? You know, they can pull more power from here. It doesn't go through the coil, and a small amount of hum here is a small factor in the output of the tube. So you can afford to have a bit of ripple in the supply to the output tube on the plate. Now everybody else is getting it from here, so we can see a B plus line running through the radio, feeding the other tubes, and the B plus from here going straight up to the screen grid. So they're getting their supply from either side of this. That's quite interesting. So if I find voltage in both, like proper voltage, then we know this is okay, everything's okay. If I find voltage on like the grid, the screen grid, but nothing on the plate, then could be open transformer here. That's what we could be dealing with. 235 volts. Look, someone's written 65 here. Also, doesn't look like the draftsman did that. And over here too, 65. And up here, okay, 65. That must be the voltage out here. That's really low. That's crazy. 65. Okay, I'm getting distracted. Let's not get distracted. That'll come down the road. You know what that says? 165. 165. This could be 65. This one. Okay, enough of that. There's the what are they showing here? They're showing grounded. They're showing the voice coil. They don't show a hum coil in here, but I saw one. Okay, let's do the voltage measurement now. I think we're ready to do it. I can even do it both sides of this. That's the same effect. Both sides of the capacitor. Okay, either way, same thing. Very good. Okay, need a little bit of practice here before I turn the set on. So I've identified, without a doubt, pins 3 and 4. This would be 3 and this would be 4. 3 is the plate, 4 is the screen. So the plate should have a higher voltage. You can tell from the takeoff point in the power supply, it should have a higher voltage. Okay, we're going to start this guy up now. Okay. And I did put the tube back in. Yes, I did. Yep. And we can also look at the top of the capacitor, which is located back here. We should really start with the capacitor, I think. Okay, are we warmed up? Hard to tell. We're operating with 100 volts here. That's good. That's good enough. Just probably that very faint hum. I'm not going to stick my ear down there though. Okay, so let's go for the power supply. Lots of red wires coming from this terminal. I've got this on the 500 volt scale. I did this yesterday, didn't I? I did this yesterday. So on the 500 volt scale, that's 175, and then the other side here was higher, if I remember right. Yeah, 220. Okay, so now we'll see what's going on down on the tube itself. This is the plate. That's a pretty convincing 0 there, and this is the screen. Ooh, 0 also. Wait a minute. Where'd that come from? Oh, because I'm pushing the probe onto insulation there. Okay, so that's screen. This is the plate. This is bad news. This is bad news. Because we have voltage on one side of the speaker coil, and none on the other. That sounds like an open field coil. That's an unusual thing, I think. Field coils are pretty tough. So the field coil wires are going through this hole here and heading up there. How's that going to help? It's all insulated up above. I can't get the voltmeter onto it. Well, let's double test, double check, because this is potentially a condemnation of the whole radio right here. The end has come. Well, I just can't imagine that's not making contact. And then if we go on the screen, there it is. So another possibility is a short in a capacitor. I don't think this is the case though. Let's take a look at the schematic again. What we're looking for is what can pull the voltage down on the plate. There's no voltage here. There appears to be voltage here. Now I'm testing it. I tested it here. I found the voltage. Here I found the voltage. Just fine. Here I found the voltage. Here I did not. The only thing standing between these two test points is this coil. Wait a minute now. Wait. Back up. Not that coil. This coil. This coil. This coil. Okay, hold on. So same sort of thing. If this is open, there'd be B plus everywhere in the radio, but here. That means the entire radio is operating except we can't hear a thing. How could we sneak out some sound here and find out? Well, we could contact the grid of this tube with my signal tracer and see if it's all there. The grid would be here. We could see if something's there. Oh, let's try that. That sounds like fun. Any signal, making it there. And this is pin number 1, 2, 3, 4, 5. That's a tough one to get to. Okay, I'm going to take a little break and prepare for this. Okay, so the idea is to listen to the signal that's on the grid of the output tube and see if the radio is actually working all the way to there. So this is the input prod for my signal tracer. It's this guy here. Let's switch them on. Okay, so this is set to audio. So it's once it warms up. Okay, there we go. Okay. So what I've done in the radio here is I don't want to reach in with this probe because we're going right past the 120 volts here with this probe. I don't want to do that. So I put a clip lead in, and the clip lead is just clipped to this piece of wood out here so it doesn't fly around. And I should be able to just touch it there and we'll hear whatever the radio is producing, and it'll be volume controlled. Okay, so I got the radio off right now. We're going to turn it back on. There we go. Usually you let these things warm up till you hear them, but we're not going to hear this one. Okay, checking the voltage. It's 100 volts again. That's plenty. Volume is right down right now, so we're going to touch this. Just a hum. Okay, that's the radio. We'll tune it a bit. It's a radio with no antenna. Maybe it's on broadcast band. Okay, let's just turn this down. Make this a little easier on me. Do that. Full volume. Touch the antenna, Jim. Okay, volume down. Halfway. That's not very good. We would hope that would have an influence. Okay, we'll try the band switch here. Volume down. Volume is down. It's not so good either. In this position, we don't hear much of a hum. You hear a hum there. What would, I don't know. Nobody home there. Volume's up full. This is a sick puppy, this radio. So I was kind of convinced at first we could hear the radio. What happened? What happened? To 99 volts, so it's still the same voltage. Yeah, what happened there? Huh. It is working. Well, that's weird. Okay, that's really weird. It's picking stuff up. No, wait a minute, I'm on the broadcast band, so it's using this. Aha. But it sounds like it's picking up some kind of shortwave stuff. Okay, you know what I can do? Give it the boost. Now, this... Well, that just quieted it right off. Interesting. Put this on the outdoor antenna. I have not got the antenna switched on in here, so this won't make much difference yet. Let's just see. And where's the capacitor here? I want the capacitor mostly closed. There you are. So I'm going to go turn this antenna on. Let me turn the volume down because I think it's going to get quite a bit louder. I'll leave this on. It takes me 12.2 seconds. A little better. Volume not making any difference. Well, that's another weird thing. Huh. Well, why is this making no difference? So I can pick this up. I can do this from another location here. We can do this right on the volume control. Let's do that. I'm going to take this off. Checking the volume there. Put my hand on the volume. So this capacitor here, this one here, is carrying the audio. We just have to get this close. This is very interesting. Can't say I've ever done this little experiment. I mean, I've noticed it before, that you just need to get the probe close at times. Well, that's interesting. Fool around with that someday. Let's check the signal here. Let me turn this down. So there's a capacitor that ties the output of the volume control, which I'm going to turn about halfway, the output of the volume control on into the radio. So I'm going to go on the far side of that capacitor. Makes no difference. That's weird. Okay, we'll go on the input side of the capacitor. Where it works better when it's just floating in the air. Okay, we'll go on the input line to the volume control. Just make sure what I'm doing here. Yes, okay. This is the input. So, well, I didn't even touch it. So this is a wide open volume, if you like, at this point.
Technology in its latest product line, meeting Energy Star compliance.
That's what's there. Gets to the volume control and okay, at the volume control. And at the volume control output. There's just nothing left. There's nothing left. But it's all there going in. Okay, well, this is kind of a bad situation here. Let me turn this off. God, I'm going to forget. It looks like the field coil is open on the speaker. That will ruin the power supply, but only the... Wait a minute. Wait a second. If the field coil is open, how did the rest of this radio get its B+? What, my thinking is confused? Probably. Do you know what that means? Coffee break time. Okay, forget the coffee. What I'm doing is I'm getting, in my head, I'm getting this coil mixed up with this transformer. But the news isn't any better. If this line is supplying B+ to the radio, and it appears to because the whole radio works. So that means this coil has to be good, which is almost certainly the case. It's just a coil of wire. What can happen to it? But if you're not getting any B+ up here, but it's appearing down here, as it does appear on both sides here, then this is implicated as being open. This is really, and this is much more possible, that this is open circuited here. So we can do a little more testing of this because it's a little more exposed. In this radio, it's mounted high on the back of the speaker, so we can get at this guy here. Yeah, so confused thinking, and I think it's coming from the fact that this looks like a resistor. I keep forgetting there's a coil here and thinking all kinds of stupid stuff. Okay, well, we have to prove that this is open circuit. One way would be a resistance reading from the plate connection here back to here. I could do that. That would work because the plate is an open circuit here, so I can, if it, whatever the reading is, will be real. It even wrote the amount here, 500 ohms. We should find. I'll have to do that test next. Okay. Now I'm going to have some coffee. Behind the scenes here in my world, I am almost steadily, say every 3 days, I get a phone call from somebody who wants me to fix their CD player. That it won't. It's an expensive CD player from the 90s or something like that, and probably a belt is broken in it. And every time I tell them no, I don't want to do it. Blah 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 blah. But the next thing you know, I get talked into it. So once again, I got talked into doing somebody's CD player, and I don't put those on video here. I just do them as best I can. So it's almost always a broken belt. I got a pretty good set of belts here. So anyway, enough of that. Right, so we're going to try to figure out in a positive way whether or not the put this off, yes, whether or not the output transformer, which is this guy here, whether or not he's defective. So we've got two wires coming into it, and we have the two wires going out to the speaker. Okay, and these wires, they won't be bared anywhere, only underneath. So unless I want to cut those wires or clean off some of the insulation, we got to work from down here. So those two wires, let's just be sure and look at the schematic here. Those two wires from here, one goes to the plate, and so I have to test between here, plate, yeah, what am I thinking? Plate and here. I could be a little confused about this versus that. You see what the draftsman has done here? Anywhere the wires end like this, where you know there must be a connection here, he has not put a dot. See, no dot. But anywhere wires cross like this, where there may not be a connection, he's put a dot to clear it up. But they're using the hop technique to show wires that don't connect, which I like this very much. You know, the visual power of these things is much more than you might realize. Like I'm having trouble with this, visually presented incorrectly to me, and in my head I can't handle it. I can't handle it. Okay, let's do this test. So resistance between plate and top of this capacitor should be 500 ohms. Okay. This is a sad moment here, because I'd put money that we're going to find out that this guy is pooched. And blown output transformers is actually a fairly common thing, although I've almost never encountered it myself. I just heard it's very common. Okay, so I want to go plate to the top of the capacitor. So the plate, I'm sure, is this one right here. And the capacitor, I'm guessing which one it is. I'm going to guess it's this one. Come on, man, show me some resistance. But maybe it's the other one. Somebody show me some resistance here. It's supposed to be 500 ohms. I'm on the 6K scale. Well, the next step would be to open the wires going to it and testing right on the wires themselves, or finding them in the ends here and lifting them off the circuit. But the fact is, all the circuit, other alternate paths could do is cause a reading on here, and there's no reading. So all indications are the output transformer is blown. What else could it possibly be? The lead's going there. Almost certainly continuous wire from where I just tested it. Well, maybe not, because I'm testing it here. There may not be a continuous wire. Let's find out where those wires go. Easier said than done. So I have these two wires here, all going through the same hole. This is a red wire. This is a black wire. They all feel the same. The other ones are the field coil wires. 4 wires. Shouldn't there be more? How's the... No, that's all it takes. Field coil output transformer. Red wire. Red wire. Coming through a hole right in here. There's the red wire there. The red wire comes right over. Yeah, it doesn't come to the terminal I was testing. Does it? This is my blaster light here. It does not. I was testing a different terminal. Oh, maybe I'm testing the other. I print this? I thought I printed the schematic out. Let's look at the schematic again. So often the output transformer is essentially across the plate and screen, but not quite in this case, because this is in between here. Well, I'm totally lost it here. Looked at, I get the room effect just from looking at computer screens and stuff now. The room effect affects me if I stick my head in the fridge. Stick my head in the fridge, I can't remember what I was looking for. Take my head out, I remember again. Oh my, the frustrations of being a human being. Oh my gosh. Yeah, I'm going to stop for a minute. I'm all over the map here. Well, here's something I kind of wrote off right at the back, at the start, is this switch. This is a switch for turning on the phono. But if you look at the back, if phono input travels down into the radio and meets up with the same grid as the radio output from the volume control. Wow, that doesn't make much sense at all. There's no volume control on it. Am I getting this all mixed up? No. So I don't understand that connection. This should be going to the input of the volume control. Instead, it's on the output from the volume control. So basically, it's uncontrolled volume from the record player. This switch here, what is it doing? It's got a capacitor here, and it's switching it in or out to here. What's that got to do with this? Or is this the radio killer? You throw the switch, you've killed the radio, and what's left then is just the audio coming from here. But again, it's not going through the volume control. The interesting thing is, what's this switch doing? And I have not switched it. Maybe that's why the radio doesn't work. Regardless of the fact that I've pretty much proven the output transformer is pooched. Let's try it. Let's try it out here. The switch. Just to see what it does. Okay. Is this on now? Yes, it is on. So we don't hear anything out of the speaker, of course. That's kind of dumb. We don't hear anything out of the speaker, so how are you going to know what the switch is doing? Because I'm hoping somehow this will just turn the radio on. Didn't it do a thing? I suppose we can find this on the schematic. If it's killing the radio signal's there, but it could be killing it in an RF stage, if that's what it's doing. Okay, let's look at the schematic and just see what the switch is really up to. So we're looking for the phono input. There we are, phono socket. It's supposed to come in through a capacitor, which it does, and then it ties directly here, just like it does. Then how do you volume control this? Does the volume control become a killer volume control where if you move this all the way down here, you've basically applied a ground to here through the capacitor, and then that would snuff out the record player? Here's the switch. What's the switch doing? The switch is switching a capacitor to ground. What's a tone control? It's just a tone control. Is it? Or if you switch this, it kills this signal here. Goes to ground, it's gone. So the input to the volume control is gone. Now you've got this guy going in, and he has to put up with the shorting out effect of the volume control. That's got to be what's going on here. So if you have this in the wrong position, you can't hear the radio. The wrong position would be closed. It's a little tricky to look at the switch and tell which way it is, so I'll make sure it's open. But it doesn't matter. I've operated the radio in both positions. But at least we know what this is now, and I think I know how they're dealing with this. Clever engineers. But this is probably a typical technique, if I've got it right. Okay. So what? there is no way this has anything to do with what's going on over here. So no B plus, but B plus here. No resistance when it should be 500 ohms, or no conduction. I don't think how can I possibly conclude anything but this is blown. I'm trying to be as hesitant as I can because it's a kind of terminal for the radio. I don't have another one of these. This isn't mine, and I don't have a speaker like that. Chances of having exactly the appropriate speaker or one that you can fit in is really quite low. An interesting alternative for this radio, and you'd have to be a little technical to make use of it. This can be an output. This can be used as an output. So you would leave this open. The radio signal would come through the volume control and head this way, but eventually not make it to the speaker because it can't get past this transformer. In the meantime, the signal is sitting right here through this capacitor right onto the phono socket. So if you hooked up a amplifier here, you would hear the same thing I was hearing through the signal tracer, and this radio would become operational if you have the amplifier and speaker to attach to it. That's an interesting way of saving this radio, and you could, I suppose, this is actually kind of interesting. You could plug this into the back of your stereo and have the sound come out of your stereo. You'd have to flip a mono switch or do something to make this both, operate both channels. Well, that's an interesting thing because I don't know how to solve this problem here. In my own operation, in my own radios that I listen to, almost all of them are fed through a common amplifier to a common speaker, and I have a mixer board that I can select which radio I want to listen to. It sounds like a bigger deal than it actually is. So this radio would fit right into that because I would just take the output from here and stick it into my my system, and bingo, this radio would become usable. But then there's nothing really, this is a great radio in itself, but it doesn't compete with the ones I have. I don't know if I would ever turn it on. It's not my radio anyway. Well, I got a few things to think about here, so I'm gonna ponder this a little bit. Okay, while peering into my coffee cup, I decided let's just give it a try. I can give it a try in my shop here. I can plug something in here, and it'll go over to my mixer board there, and we'll all be able to hear it. Particularly if I put headphones on, I'll be able to hear what's coming out of this. And we'll see if we can kind of do a reverso on it. First thing I want to make sure though is that there's no voltage on this connector. These old capacitors in here still, and maybe something's leaking across. I don't know, so I'm going to check it here before plugging it into before blowing up my video sound system. So okay, we'll put this down to, let's say, 50 volts. And oh my gosh, this is on. Oh my gosh, I left this on? Holy jumper. Shame on you, Jim. I came in here not realizing this is on. Oh, I got to put a light bulb in up here before I get myself into big trouble. Okay, so we're looking here. It's been on for a while. That's good. I don't see anything happening at all. We're looking here. So I don't see anything happening. She's a 0. Tiniest little movement there. Okay. that's good. So, headphones for me. Okay, because normally I don't listen to the audio that you're listening to. I don't monitor it. I just watch the volume level indicator, but occasionally I do put on headphones because I got to hear what you're hearing. This is a case of that. Okay, I don't need this. What I need to do is grab the here it is. Okay, first of all, we're gonna test this. I'm gonna up the volume. There we are. So this is going into the line input on my setup there. Now, didn't I say this is unvolume controlled? No, this would be volume controlled. The volume will control. So we'll turn it down. Okay, something bad could happen as I plug this in. This is an ungrounded. No, I'll take that back. It's grounded by this. Okay, here we go. The volume is down. Good. Okay, now we'll turn the volume up. Okay, so there's nothing there. Let me turn this up half. We'll turn this up. Ooh. Well, not hearing a thing. My theory's going down the drain, or it's just really bad capacitors in here. Here, I could have done this with the signal tracer. Let me turn it back on. Hook it back up. No, not this job. This guy. Oh, that's right. Didn't that? Well, I could hear it coming in, but never hear it coming out of the volume control. Isn't that right? Okay, coming in. Oh, I had the volume right down there. Let me try that again. This is coming out of the volume control and coming into the volume control. Get it up here. Yeah, so the volume control is a big problem here. So I would have to run a capacitor from here over to here, or somehow connect this into this point. Okay, you know what? I can pull this off. I just have to stop for a minute here and get a few bits and pieces together. Okay, let's pick it up from here. So I have this guy, which I can do this with. And I have this clip lead here. I think I better just measure the voltage at that point before I get too far into this and have a surprise. So this point here. Ooh, do you see that thing go? So negative. Yeah. Yeah. So we definitely need a capacitor in this thing. 15 volts, so we got like 3 volts sitting here. And is that by some chance an ADC voltage? Whoops. Yeah, so we have an ADC voltage. Look at that. Beautiful. That's fantastic. But I don't want that coming out on this audio. So I need a capacitor with a clip lead on it here. Let's try this one. And go on here. This will just be on the ground, on the chassis. I think I'm going to take this off first. Put this here. Gotta watch those flying clip leads here. Okay, so we're gonna go on like this. Okay. Now, order of things. So I'm gonna plug this in here. We're gonna turn up the volume and double check. Should be able to. It's not so good here. My cat bit through this. Seems okay. I keep bumping this with my hand. Okay, so volume down on the soundboard, because this is uncontrolled volume. And volume up. Just a tiny amount. Now the tunes.
Fueled run, though the rush to get the chips out the door is proving pricier than expected. Seems traders looking at the positives of NVIDIA's earnings report over the negatives. NVIDIA slowly made a turnaround. Right now, shares are moving higher after initially. Wall Street's index is splitting it. Dow gaining 0.5%. NASDAQ down almost 1%. S&P 500 little changed. Andrew O'Day, Bloomberg Radio.
And right now, the S&P TSX is up 171 points to 25,208, and our loonie little changed at 71.7 cents.
TSX is a Toronto Stock Exchange. Okay, let's try another band. Why not? So we'll go one click. I don't know what band we're on. There's no volume there. It's over here on the soundboard. Ooh, that's full volume. Oh, because there's no antenna connected. Oh. Okay, let's turn this up. What happens if I touch this? You can hear it a little bit. The link falling out. Okay, so I'm going to take the antenna off the loop here. I'm going to hook one lead here. And just turn the volume down so we don't get our ears blown off. Here we are. Just the one lead for now. Okay, turn the volume up. It sounds a little different, doesn't it? So we don't know what band. Doesn't seem to do anything here with the tuning. That's a little odd. Okay, I'm going to attach this ground to the ground here. Volume down again. Just put it on there. Okay, it doesn't seem to have made any difference. Maybe there's a little more volume. A little more. Well, that's odd. Nothing. Okay, try another one. Volume down. Now, which way am I going with this band switch? Okay, that's AM that we just tested. Next band. Here we are. Sounds exactly the same, doesn't it? Well, that indicates something right there. Exactly the same. Okay, let's go another band. I won't even turn it down this time. Exactly the same again. So we got something more going on. Now I'm going to go back to the broadcast band. I'll just turn the volume down a little bit before we do that. Sorry about the volume. My headphones are low volume-wise. I tend to turn things up a little high in here, and then it's too high on the video, and I don't notice. So I apologize if that's happened. It's an old radio, receives old music. Okay, I think I've done enough fooling around here for now. I got to ponder the situation, how to get value out of this radio. I think I found a way to do this in a very, very simple way. Because overcoming the output transformer problem is much more difficult. And I don't think I have a spare transformer or speaker or anything that's going to help with that situation. So I very much like solving these problems with what I have at hand. You know, use what you got to get more of what you want. Use what you got to get more of what you want. Do you know that is the fundamental law of economics? That's what economics is. It's using what you got to get more of what you want. That's economics. So there you go. Lesson. There's a lesson for you. That's the fundamental rule. You probably never hear anybody ever say it. There you are. It's really receiving quite well, but then it's boosted with a very strong boost here from an outdoor antenna.
Over this green tech fund, the only thing that can change that is support from another party.
Trudeau is set to make this GST break announcement here in Toronto shortly. A man has been arrested in the stabbing death of his own father at a home in Scarborough.
Oh, okay. I shouldn't have let that go on. Okay, that's it for today. I will spend the day pondering the situation here and decide what to do. I'm guessing what I'm going to come up with is let's clean up the capacitors and make this attachment permanent, and that's it for this radio, with a big note written on it how to use the radio. Otherwise it's a dead dog, and who wants that? Okay, thanks a lot for watching, and have a great day.